Bismillahirrahmanirrahim. Welcome to my new lecture, dear students. Today our lecture is about the isotonic solution. That what is isotonic solution, hypotonic and hypertonic solution. So I'm going to differentiate between all these terminologies. So I'm going to start the lecture from the isotonic solution. So isotonic solution can be defined as when two solutions having same osmotic pressure and salt concentration are said to be isotonic solutions. Iso means same and tonic means concentration. So let's suppose if we have two solutions and two solutions having same osmotic pressure and they having same salt concentrations, mean the solute and solvent concentration they are present in equal amount, so we can say it is said to be isotonic solution. So iso mean same and tonic mean concentration, same concentration present on both sides. Physiologically in chemistry and pharmaceutical chemistry, and you can say physiologically the isotonic solution, they are solution having the same osmotic pressure as that of the body fluid when separated by the biological membrane. So the biological fluid including blood and lacrimal fluid normally have an osmotic pressure corresponding to that of 0.9% weight by volume solution of sodium chloride. So thus 0.9% solution of sodium chloride is said to be isotonic with the physiological fluids. Let's suppose of the solutions of 0.9% which contain sodium chlorides, so that is said to be isotonic with the physiological fluid. How? Moreover, I would like to say in additions to carrying out the pH adjustments. So as we know that better, that pH is the negative logarithm to the base 10 of the molar concentration of hydrogen ion in aqueous solutions, and it is also clear that the normal physiological pH of the body is 7.4, which is neutrals. So for pH adjustment, the pharmaceutical solutions that are meant for application to delicate membrane of the body should be adjusted to appropriately the same osmotic pressure as that of the body fluids. The isotonic solutions cause no swellings. There will be no swelling or contraction of the tissue with they come in contact, and they produce no discomfort when instilled in the eye, nasal tract, blood and other body tissue. So isotonic solutions, sodium chloride solution, it is familiar to pharmaceutical example of in such preparations. It means that let's suppose we are going to prepare a different type of solutions, you can say in the form of parenteral preparation, in the form of injection, so it can be easily administered to the patient because the solution is isotonic. So you must will have to maintain the concentration of the solute, you must have to maintain the concentration of the solute, as well as you will have to maintain the concentration of which having same osmotic pressure. Now look at here, 0.9% weight by volume solution of NaCl has essentially the same concentration and osmotic pressure as the red blood cell contents. As we know that the normal human body contains 4.5 to almost approximately 6 liter blood. So it means that how much blood they are present in the human body, so it must be circulated. So here the point which is mentioned here is that let's suppose if you have 0.9% weight by volume solution of NaCl, so it is very important for what? That the same concentration and osmotic pressure as the red blood cell content. Thus it is said to be isotonic with the blood. It means that if the solutions having 0.9% weight by volume solution of NaCl, so it means that if this concentration 0.9% weight by volume solution of NaCl that is present, so we can say that the solution must be isotonic with the blood, and then it can be compatible. So why, let's suppose we are going to administer different type of injections, infusions, or it may be it can be injected intramuscularly, or it can be injected venously. So why? The reason is that all these preparations, so its isotonicity, it will must be maintained and it must be adjusted with the body in order to maintain the equilibriums. So it is also known as physiological saline solution, or you can say normal saline solutions. It is also known as normal saline solution. If, let's suppose, look at here, this point is very important. If the red blood cell, they are suspended, let's suppose if the red blood cell, they are in suspended position and 0.9% solution of NaCls. So it means that if the red blood cell, if they are suspended in the solution of NaCl, which is 0.9%, so they undergo, there will be no change occur in their size and shape due to isotonicity. It means that if the solution is isotonics, so it means there will be no change occur in the shape and the size and the morphological characteristics of the red blood cell due to isotonicity. Now I'm going to differentiate the difference between isotonic solution, hypertonic solution, and the hypotonic solution. Now what is hypertonic solution? So hypertonic solutions mean the solution that has a greater concentration than the reference solution. The reference solution means, for example, the red blood cell contents which are present in our body. So it must be compatible with them. Let's suppose if the solution concentrations, that solution which is greater concentrations than the reference solution, then you can say hypertonic solution. Now let's suppose if the solution become hypertonic, so what will be occur with the red blood cell, or either if the solution become hypotonic, so what will be happen to the red blood cell, RBC. So the at the here, a hypertonic solution has greater osmotic pressure than that of reference solution. So it is clear. It means that, as we have discussed in isotonic solution, that the solution which having same osmotic pressure and same solute concentration that is present, at two solution they have same osmotic pressure. Here the case is different. In hypertonic solution, that is greater osmotic pressure than the reference solution. Reference solution mean, for example, RBC content. Now in this case, if the red blood cell, they are suspended and 2% weight by volume solution of NaCl, like isotonic solutions, as we have discussed already. So let's suppose if this red blood cell, they are suspended in 2% weight by volume solution of NaCl, for example, this is hypertonics. So then the water molecules, it will be present within the red blood cells, and you can say it will come out due to what? Due to high osmotic pressures. So it means the situation is going to be saturated. So the situation is going to become hypertonic. It means from the condition is going from dilute red blood cell fluid to concentrated. So it means that from dilute RBC, the fluid lead toward the concentrated hypertonic solution, and to the surrounding to dilute the NaCl solution, hypertonic solution. So this definitely, so this will exert the water from the RBC causes, and there will be occur shrinkage. You can say broken down shrinkage, and the RBC become wrinkled in shape. So I mean that, let's suppose if the red blood cell, if they are suspended in 2% weight by volume solution, so simple, if RBC is suspended, if they are suspended and 2% weight by volume solution of the NaCl, so it is very, this point is very clear. I mean that if the solution is hypertonic, so there will be the RBC, after the RBC, there will be occur shrinkage of red blood cell, and the RBC, it become wrinkled, its shapes, its structure, its morphological characteristics will be changed. It will be changed. There will be occur alterations. So the shrinkage of red blood cell, it is known as plasmolysis. So when the RBC, why the red blood cell, why the red blood cell, it become broken down. So why plasmolysis is occur? Because of this reasons that the waters molecule which are present in the red blood cell, it will come out due to high osmotic pressures, mean from dilute red blood cell fluid to the concentrated and to the surroundings to dilute the NaCl, and the solution become hypertonic. So it means that hypertonic solution, they are not applicable for the biological activity. The second one is hypotonic solutions. Hypotonic solution is that solutions which has lower concentration than the reference solution. The reference solution means, for example, RBC content. So the hypotonic solution has lower osmotic pressure than that of reference solution. Here the condition is different. So as we have already discussed in hypertonic solution, that in hypertonic solution there is the osmotic pressure will be high, while in this case the osmotic pressure is low. So it means then reference solution. So let's suppose look at the case here. If the red blood cell, they are suspended at 0.1% weight by volume. Why? Because the osmotic pressure here is low, so that's why it becomes 0.1. Look at the difference. Here is the RBC, they are suspended in 2% weight by volume solution, and in case of what? In case of hypertonic solution. So here the case is different. So what will be happen? If the RBC, they are suspended in 1% weight by volume solution of the NaCl, for example, the solution become hypotonics, mean decrease the concentration. Hypotonic mean, hypo mean decrease, tonicity mean, tonic mean concentration. So then the water molecule from your solution will be enter. So here the RBC, for example, due to osmosis from dilute hypertonic solution to RBC, red blood cell fluid, to dilute the fluid within the RBC, causing their swelling. So there will be occurred swelling and imbibitions, which may result in the rupturing of red blood cell, and release of hemoglobin will be take place here. So let's suppose if a solution which is hypotonic and it has low osmotic pressure and it doesn't maintain the concentration of the solute. So here in this case the red blood cells which is mentioned here, that the red blood cell causing their swelling, which may later result in rupturing of RBC, and release of hemoglobin will be occur, and the rupturing of RBC is known as hemolysis. So but this point is clear. This point is crystal clear that let's suppose if the solution become hypertonic, so there will be plasmolysis. If the solution become hypotonic, so there will be hemolysis of red blood cells. So I am going to show it in the diagram. Look at here, these are the red blood cells, and these red blood cells, they are put in different solutions. So this is isotonic solution. So as we have discussed already, this is isotonic solution, is osmotic pressure is maintained here, and this is what? This is hypertonic solution. Osmotic pressure is lower than this, and his osmotic pressure is higher. Now look at here. So this is the condition. Look at the shape of red blood cell. So here the red blood cell shape at same to be like that. There is no change occur in its morphology, at structure, shape and size. And here in this case, look at here, in case of hypotonic solution, so its shape it become change. You can say in the shrinkage, you can say the hemolysis of red blood cells occur here. So when hemolysis of red blood cell occur, solution, and especially in case of hypertonic solution, so here in this case plasmolysis is occurred. Look at here, the red blood cells, so it become broken down, shrinkage of red blood cells occur. So further in the next figure you can check it here. So this is another classical example. These are what? These are red blood cells, and this is the solution of, you can say these are red blood cells, and its isotonicity is already maintained. And look at here, this is hypertonic solution. It means the shape, the structure, the overall framework of the red blood cell, they are changed. And this is hypertonic solution. Now here, look at here, an isotonic, look at the RBC. So in this case, mean the water molecules, the influx, this is equal to outflux. And look at here, so the water molecule, the water, they are lost. In case of hypertension, hypotonics, in this case in hypotonic. So as we have discussed that if the solution become hypertonic, so here plasmolysis will be occur and the water molecule will be lost. And here in hypotonic solution, so there is occurred, look at here, the water molecule, they are going to penetrate inside the red blood cell. So the RBC becomes swell up, and what will be happen? So there will be occur shrinkage of red blood cell, and you can say when the shrinkage of red blood cells, so definitely here you can say plasmolysis and hemolysis will be occurs. In case of let's suppose if the solution become hypotonic, so plasmolysis will be occur in this case. Sorry, you can say hemolysis will be occur in this case. In here plasmolysis will be take place. Now I'm going toward iso-osmotic, or you can say ISO-OSMOTIC solutions. Now what is ISO-OSMOTIC solution? So ISO-OSMOTIC solution having same osmotic pressure but not necessarily the same concentration, they are said to be ISO-OSMOTIC or ISO-OSMOTIC solutions. For example, look at here the case is difference. So for example, if we have 2% weight by volume solution of boric acid and it has the same osmotic pressure as 0.9% weight by volume solution of NaCl as we have discussed, but not the same concentration, it means the concentration is different. Look at here, here is 2% weight by volume solution of boric acid and it is the same osmotic pressure as 0.9% weight by volume solution of NaCl, but not the same concentration. So both the solution, they are, you can say, an iso-osmotic but not isotonic. It means they have same, you can say they have same osmotic pressure but they are not isotonic. Inshallah, the next lecture, inshallah, it will be discussed in my second lecture of this class. And thank you so much.